G'day comrade subscribers. So what we have today is an East German Robotron KC 87, where the KC stands for Kleincomputer or small computer. So not to be confused with the KC 85/3 that we've had a look at before. So this series was, I think these were made in Dresden, whereas the 85/234 were made in Mulhausen. So different factory or different kind of concern or whatever, but under the Robotron umbrella, I guess. So this was originally, I think it was originally called the Z9001, and it came out in 1984. It's based on the Z80 or the U880 clone. Then in 1985 it was rebranded as the KC 85 or the 85/1, and then in 1987 we've got the KC 87. So like I said, these came out of Dresden, I think, and whereas the other machines, which are more kind of modular, I guess, you've got the KC 85/2/3 and /4. They came out of Mulhausen. So I'm gonna have a look. It's nice metal case. Weighs a few kilos. This has come off, so I need to stick that back on. We're gonna have a quick look at the back. It actually gives you all the information there. VEB Robotron, Mess Elektronik, Otterschön, in Dresden, in der DDR. So East Germany, or the GDR, KC 87.1, blah 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 blah. So what we have on the back, so you can see it's got an internal power supply, 220 volts as it expects, 30 watts. Got a fuse holder, and we've got the very kind of sticky on-off button. So that's something that's going to need a look at. Nothing much on the bottom. Got two plastic kind of feet here. And it looks like we probably had the same up here, but they've come out. So it actually looks like they push in. Nothing on this side, but we've got all the ports on this side here. So I'm not sure. I guess this is some sort of expansion port. Then we've got the good old magnetophone, so cassette. Then we've got ports labelled 1 and 2. So I think this one is joystick, and I think this one might be RGB. You can see they've got a different pin out. So I think this might be the RGB out, and then we've got obviously UHF out. So hopefully I can use this one, although I've heard the sync is a bit weird. So someone else has done it. Can we zoom out a little bit? There we go. Otherwise, actually we can zoom back in. We've got 4 expansion ports up here in there where cartridges or modules can go, similar to the KC 85/234. So this one's got basic KC basic built in, whereas the earlier models, the original Z9001 and maybe the KC 85, you had to load basic in either by tape or having it in the cartridge. I got this pretty cheap, so I don't have any RAM expansions or anything like that, unfortunately. I've just got the machine itself. I don't know if it works. I'm a bit wary of just turning it on, because it's one of these machines, while the power supply outputs ±5 volts and ±12 volts apparently, although the negative 12 volts I don't think is needed in this iteration. So what we'll do is, like what I used to do on all of the teardowns, is that first thing is we'll have a look at we'll pull it all apart, and in this part we'll have a look at the power supply. Because what I've read is they basically had to replace most of the logic because the power supply wasn't working properly, and some voltages were missing, which basically screwed up all the East German and Soviet chips. So I say I'm not confident it's going to work, but we'll look at the power supply, see if the power supply's behaving, and well, maybe try. But we've got to do a RGB cable anyway. All right, so pulling it apart. So I've got a pair of screws on the back here for this top part. I can't see any other screws external, but opening up this, there's a little bit of flex in it. You can see we've got additional screws here and probably over on this side. So this does move. I don't know exactly how this is supposed to come off. Maybe on this side here. Is it going to come off a bit? Because on this side here we've got these little tabs that hook in. So I'm wondering if we've got tabs on this other side here that hook in and that we can just pull out. Because I'm assuming we've got similar two screws there as well. All right, let me have a fiddle. Done the back screws. Yeah, so there's definitely these two screws here have got to come off somehow. There we go. Just had to do it a bit more. Is it going to pull out, or is it just going to? I think, does that just lift off these metal things here? So that's obviously here to hold the cartridges in place. Okay. There's a screw there. Let's get that one out. Okay. I think that's holding. There we go. That comes out now. So we're getting to the power supply. I've got to, when I was taking these screws out, the washer over in this corner over here disintegrated, so there's a bits of washer floating around, so I'm going to have to try and find those. Let's get this front one off. It certainly looks to be a lot easier to put back together than the 85/3. Alright, so this is going to come off then. Like so. Okay. Oh, I could respray it. I could change it a different colour. Keyboard's in there. This I assume just lifts out as well. Okay. Wriggle all the loose stuff out before we power it on. So that's obviously the power supply there. Well, that's interesting. Got a connector here for the keyboard, and then it looks like there's a free connector there. Okay, the middle's a bit bent. So I guess the keyboard could come out like that. Power supply. Okay, looks like, let's do the keyboard next. So far it appears we've got all the same screws, which is good. You have to try and remember which one goes where. We had a massive storm yesterday. Actually lost power for about an hour. Just decided we were going to get pizza takeaway, well, pickup. just managed to put the order in online when the power went out. Of course, worst case is, we could have just made hot dogs, cook some sausages on the barbecue. Okay, there's the keyboard. It's pretty well made, actually, considering such crappy key switches. Alright, that came off pretty easily. So there's the keyboard module. Looks like it's kind of, what's the word? Not riveted, kind of riveted together with these things. So, unfortunately, it's not going to be easy to pull apart. Although, having said that, there are these metal tabs here, but I don't think that's going to help you at all. So it would be nice to give this a bit of a clean. All right, well, we'll put that aside. Whoops. Right. You see a lot of East German parts. 855, so they're probably what, 8255 equivalents. Peripheral interface adapters or whatever they are, vias. Got the CPU down there, the U880. Mixture of Soviet parts and I don't know, perhaps Slovak parts. I'm not sure. Yeah, we've got some Tesla here, so we've got some Czechoslovak parts, we've got some Soviet parts, we've got some East German parts. Don't see any Western parts. Ugh, these bloody big decoupling capacitors, sharp edges. Well, they love their sharp edges on these things. All right, well, let's have a closer look. Here we go. So, like I said, it looks like we've got some, I think those are German, I'm not sure, East German. And we've got some Soviet parts. Got some nice wire wrapping there. Got some nice wire wrapping over here next to the CPU. So that's the Z80 clone. We've got these wonderful, we've got some more Soviet parts there. Actually, that's the RAM by the looks of it. That'll be the KR565 RU5, 64 kilobit. 1, 2, 3, 4, 5, 6, 7, 8. So 64 K of RAM. There's a crystal. Yeah. So quite a mixture of parts. Now I think we saw some. I'm just wondering if those 740SO4. I'm not sure where those parts are. They seem to be the same. So I don't know if they're East German off the top of my head. But yeah. And we've got that'd be our UHF modulator CAN. Then those will be the interface adapters. So UB855. So I guess 8255 equivalents. I guess. UB857. I don't know what that is off the top of my head. I'm not sure what that one is. I did see a Tesla part somewhere, so Czechoslovakian. Oh, there we go, there's a Tesla part, MH3205. I've got some of those, spare. Got some more large chips there. So we had a look at the wire wrap, didn't we? Some pretty cool wire wrapping there. So what was these ones? Oh, Siemens. So they actually got some West German parts. There we go. Some West German parts. That's interesting. So this is 1987. This came out. Okay, and then we've got the that's the 4 expansion boards there. And then obviously we've got the power supply there. So power supply looks nice and easy to disconnect So we've got 5N, 12N, so that'll be what, negative 5 volts, negative 12 volts, positive 12 volts, and like positive 5 volts, and that'll be the ground, I guess. So like I said, I'm not sure if they use all the voltages, but it would be good just to check the power supply. So I'll pull that out. Actually, I don't need to pull it out, but I can just disconnect these and check the voltages. Not sure what that is for. Something spare. Okay. There's our side ports there. Should I get the power supply out? Or if it just lifts out or something. I'll have a look. So the reason why I thought we could lift this out maybe is you've got these here. So it looks like if you just push this in, that metal tab in, and then this will, using probably a screwdriver, that'll flip down to the side there. So there's 4 of those. So something might lift out. Let's see. Yep, I've undone those tabs. And if I just pull off these power supply wires, I think the whole module, yep, there we go. The whole module just lifts out. Okay, these plastic things, okay. So I was held in with these plastic things, and then those clips hold it in. So that's a neat little design. So power supply's out, so worst case, you could replace the power supply with a modern version. So let's put this aside and have a look. Right, the power supply. Actually, these two kind of spaces on the side, they look to be the same as the feet on the bottom of the machine. So I could actually take these off and replace the ones missing on the bottom of the machine. Maybe I just replace them totally. Okay, so like I said, we've got, I didn't say, but we've got, looks like basically a C7, IEC C7 standard plug. The on-off button was a bit sticky, so I might give that a bit of a spray. Got the fuse there. So I'll give it a quick spray. It's a bit better. We'll have a quick look inside, just see if there's anything blown before we power it on. Okay. Actually, as I was doing some research just to try and find pinouts and stuff, I found a very an interesting video. Like it's an ASMR. Well, they're German, so they're weird to start with. But it is like an ASMR type video where the girl's like, you know, whispering into the microphone like this. But they've also got flexible nails. So it's like, yeah, I'll put a link to it in the video description if you want to take a look. Oh, that's a big capacitor. So I don't think, just trying to see if they've got any, so using any regulators, linear regulators, but I don't really see any. So I guess this is the rectification section here. Transformer, I guess smoothing capacitor. And then, okay, all the voltage stuff is done down there, I guess. I don't want to open it up too much. It looks like we've got a big metal, can't really see it, but something down the bottom there. But there's nothing, obviously, that's the other thing we need to check for is blown safety capacitors, I guess. I don't see anything obviously blown. Zoom in for you guys. Looks like there's some relays down there. Oh no, what do you reckon about that one? That actually looks like maybe it's blown. But it's usually, if the safety capacitor is blown, it should still work, because as long as it doesn't short to ground or short to earth, then it'll still work. But obviously you don't have the benefit of it. But as long as it hasn't shorted to ground. So that one might be, that one looks a bit dodgy, doesn't it? Don't know if I've got a replacement for that. Let's just power it on and see what voltages we get. Alright, power on at the switch there. Oh, that was already on. Okay, so that should be on. Let's check voltages. So yellow is 0 volts. So yellow is, that's ground. And black is supposed to be plus 12 volts. Which is nothing. And nothing there. Okay, so there's no voltage output at all. I can't even hear a whine when it starts up. So I'd say, well, of course, we should check if the fuse is okay, shouldn't we? Or that it has a fuse. And oh yeah, no, there is a fuse in there. It's hard to tell. Let's just do continuity check. Nah, fuse is blown. All right, well, that's the first start. Okay. Let me check. What did it say? I think it said half an amp. So we need T0.5A. So a slow blow, timed half amp, 500 milliamp fuse. So I've got a couple. Well, I've got 3. So I don't trust. I don't know what that is in there. So let's see, I'll just try it, and if it blows straight away, then we know we've got a short. Put that on. Okay. All right. Let's give it another try. Zoom in a little bit, just in case if it does blow, we might capture something. Okay, it's off. That's in. Power is on. So far it looks okay. I can't hear any whine. So what was it? Yellow. Yellow was ground. I'm on continuity at the moment. DC volts. And green on the far end. That's supposed to be minus 12. No, still nothing. Blue. Yeah, it's definitely not working. Minus 5. Yep. No, it's definitely dead. I feel a bit of humming. You know when you can, when you touch an AC and you get that kind of humming on your fingers. Okay. So something's not working in here. Is it worth trying to fix? Or should I just get a mean well? I've got a few spare mean well power supplies, but I don't think I've got any that do -12. Let's continue to pull this apart, shall we? Okay, it's kind of welded there. So that looks like that'll come off. That panel will come off. And oh, okay, we've got some screws at the bottom there. Okay, so it looks like these screws here, and then this will slide out if we undo these screws as well. So let's do that. Okay, so that slides out. That's one screw undone there, which means that that can pull out as well. Oh, okay, we're still stuck. Why are we stuck? That box down there. Okay, which is screwed in. Okay, that's screwed in, that's no problem. Alright, a couple more screws. Okay. Let's just zoom out a bit. There we go. Alright, so there is a little bit cable tie there. Okay. So how does that come out then? I'm thinking that once I get this out, I'm not getting it back in again. Do I have to maybe bend these things up perhaps, and it lifts up? All right. There we go. All right, finally. So one wire broke off. That's no problem. I can put that back on. Okay, so I wonder what this is. Nets 166-5551, 250 volts, 1.6 amps, 885. So August 85. So that. Turn the. What is that? I don't rightly know. 4 inputs. So the wires. Okay, so we've got AC in on the top here. And then I guess we've got AC out. So I don't know, is it a big filter or something? Where do they go? I think they go up to the switch, do they? Oh, the other one's come off anyway. Okay. Well, no, so it's AC in. And then these two, I'm just trying to figure out where these two, is it like shibari? Do they go off to the switch or do they go off to the fuse? I think they go off to the switch. So I guess what I could do is, I don't know if I'm supposed to have a load on this, but I could just connect it up to see, okay, if I've got 240 in, am I getting 240 out? Like I said, I can't hear any high-pitched whine or, you know, when you've got these sort of switching supplies. Just trying to make sure that these other two wires. Should I break off this Shibari style rope? Just so I can make it easier. Alright, let me clean this up. Okay, so one of the wires obviously goes off to the fuse and the other one goes off to the switch, so obviously flows through the fuse, duh. So alright, well, this is completely isolated now anyway. So if I just apply power into there, I should be able to see if I get any AC out of there, I guess. And this is all completely isolated. So power is off at the wall. Okay. Power on at the wall. Okay, switch to AC. Alright, yep, 240 volts. Alright, so voltage is coming out of it. So it's not being blocked there. Okay. I'm just tempted to maybe desolder. I'm just tempted just to so I've got my Meanwell power supply that does ±5 and +12 with a DIN plug, and then maybe just sticking a DIN plug on here. But let's have a bit more of a closer look. Maybe I'll do some desoldering just to try and make it a bit more manageable. I can't see anything. We'll have a closer look, but there's definitely a short there. This is the new fuse I just put in, and you can see it's darkened, so it's definitely blown. So I'm looking. I always kind of first thing I look at is the safety capacitors. So I think this is a pair of X class or class X safety capacitors. Because it looks like what we've got here, I think we've got some rectification going on here, I guess, because we've got a blue and red DC wire going down. So we might have some DC going in there. But then obviously, because we want those negative voltages, we've got also the line going into here to this pair of 10 nanofarad 630 volt class X. I think they are class X because you've got line, and then they're connected up there. So I think they're across the line, so the class X. But I can't, let's get the light in. I don't know, it does look a bit dodgy, doesn't it? And there's that there, but I don't know if that's just flux. What have I done there? So that just looks like maybe some stray solder. But I might have 10 nano in this size, so I might be able to just replace them anyway. They usually do blow, don't they? And if they do blow, I think they blow short, so therefore it's going to blow the fuse each time. But otherwise, I can't see anything. Obviously, I know Mr. Volkmann's isn't going to like this this residue here, but it doesn't look like it's come from a capacitor. I don't know. Nothing obvious. And we've got a big transistor there, big capacitor there. They're usually okay. These ones look okay as well. Alright, let's see if I can replace those safety capacitors. I'm not too sure if I really want to use this power supply anyway, but let's see if we can get it working outside the computer. So I've got, this is from the Tesla, the PMD85. I think these are Polish, aren't they? Polish Miflex. These are 100 nanofarad, I think 0.1 micro. We want 10. These are good old, what's that there? That's 100 nano. What's that say? 0.01 micro. I think that's 10, isn't it? I think that's 10. I better use those. They look like the right size. 0.1. I think these are 0.1. That shouldn't really matter, should it? I don't think it matters. 10 or 100. As long as they fit, that's the main thing. These look a little bit too big. Oh, they might fit. Alright, let's try these ones out, I think. X2, 275 volts. She'll be right. Okay. Let's get these out and give another try. Right, I've done a very temporary and very terrible job replacing because they're just too big. But this is just temporary. I don't have any small enough. I'm not too convinced because these aren't shorted, but one of them's measuring 11 nanofarads, the other one's measuring a fraction. So maybe that's it. So this one here is measuring, okay, 10 nanofarads, and this one here is also measuring 10 nanofarads now. Oh, okay, of course. Yeah, all right. And neither of them were shorted, so I'm not convinced that either of these were the problem. Something else. Normally when the fuse blows, it means there is a short, doesn't it? Continuity check. What about this? So, all right, well, I'll give it another try, put another fuse in. I guess I could check DC there, couldn't I? I've got to resolder everything. Do I need to use this? What is this? Let me try and find it. It actually seems to be the filter, X and Y class, although they're in Y class because we don't have ground or earth. So I'm just reading an article on Robotron Technique.de. So I'd like to describe my experience with reproducing the mains filter from the KC87 mini computer. It's called 166-5551 or blah 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 -X. So I don't have the -X. If anyone knows the difference, please let me know. Anyway, this information will be useful to someone else as these filters can become reliable. Okay. So one day after over an hour operation of my KC87, I suddenly heard a kind of bubbling noise coming from the power supply area. Well, I can't hear anything. The device continued to run. Well, I'm not getting any output, but I quickly switched it off. At first I thought of the primary electrolytic capacitor C3. It must be this big fellow here, is it? Well, it says it's 50 microfarad, 350 ohms, 350 volts. Anyway, however, the cover seal was okay and the measurements showed that was still okay. While the KC was running with the power supply open for testing, after a while I could hear a mains hum that was getting louder coming from the mains filter area. Well, I'm not hearing anything. After switching off, I noticed it became very hot. So using the method mentioned by Kai Orr, hot air, I dismantled the filter. It contains a current compensated choke at the input, followed by 2 parallel connected capacitors, right? 1 MKT, 1 MP without housing, plus a discharge resistor, 2 Y capacitors, and a series choke. Apart from the MKT, the components are not labelled. Decided to replicate the filter. Okay, so this is all soldered closed, so I'd have to solder it open. But I wonder, because like I said, normally it's the Class X that they're not shorted, or should they be? They have continuity, but they're not shorted, so line's not shorted to neutral. Okay, so it goes on to explain, okay, unfortunately all the photos use photo bucket and all the images are gone. Alright, we've got some other photos here. So, okay, so this is actually the filter in here. I wonder about running it without the filter then. Try it without the filter. In which case I need to run these 2 wires, I guess, up to the input and then see what happens. Okay, power should be on there, so I'll just basically bypass the filter. We power on at the mains. Can't hear anything. So either the fuse is already blown. Let's just check AC. Come on. Yep, so AC going in. Let's check AC on here. No AC. So the fuse is already blown. Right. I am at a loss. I can't see anything obviously wrong, so yeah, I've disconnected that. But I can't see, so these I've replaced, they looked okay. This is where the AC comes in on either side, and then you can see the other side of the capacitors are connected together there. I know Mr. Volkman isn't going to like the look of that. But I can't see anything that's obviously burnt. Although, like I said, that there's some flux on it, but I can't see anything obviously wrong. That's not shorted. Yeah, if I do continuity check across it, there is no short on this board. So this is a pretty big fellow. That's the 50 micro 350 volt. But there's nothing, something that's drawing over 0.5 amp. Haven't even looked at these. But everything looks okay. It's a bit dodgy. So yeah, I might have to put this to the side for now and possibly use an alternate power supply. So I'll have to rig something up, try and power it. But if I only need 5 volts, if I don't need the other voltages just to switch it on, then that might be easy. So yeah, sorry guys, I'm not very good with power supplies, but yeah, let's see. Hopefully that was an interesting introduction. Bye for now.